Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to discuss some of the questions in PSPM that is related to Chapter 10, Mechanical Wave and Sound Wave. So this is one of the question in past year question 2018-2019, question number 9, that is related to standing waves formed by the stretch string. Okay, so let's read the question first. A wire of mass 30 grams, so given the mass of the wire and the wire is stretched between 2 points 100 centimeter apart, that will be the length of the stretched wire with the tensional force of 70 Newton. So tension of the wire. When the wire is plugged, standing wave are formed in the wire. So let's list out the information given. First, the mass of the wire in grams, so we can convert to kilogram. It will be exponent -3, ataupun we can simply write as 0.03 kg. 1, 2, 3. Okay, and then we also have length of the stretch wire, which is 100 cm. Also we can convert to SI unit, which is meter. 1.0 meter. And then we also have tension of the wire, which is 70 Newton. Okay, so the first question, they ask us to calculate the fundamental frequency and the third overtone frequency of the wire. So two questions in question 1. The first one is fundamental frequency. Fundamental frequency is also known as first harmonic, or n equals to 1. Easier if we recognize the harmonic of frequency, because we know what is the number of n. Okay, so fundamental frequency n equals to 1, so we want to calculate f1. So usually if you want to calculate frequency or you want to calculate lambda, you just simply use the formula of V equals to F lambda. So that is the velocity of the wave, F lambda. Okay, so in this case, the standing wave formed by the wire. So this velocity, it will be velocity of wave formed by the wire. Okay, and we have specific formula for velocity of wave formed by the wire. That is V equals to tension over mu. So tension over mass per unit length. So mu is mass per unit length of the wire. So kita boleh kira what is mass of the wire is 0.03 kg over length of the wire 1.0. Okay, so it will be 0.03 kg per meter. So we can simply calculate velocity first. So velocity of the wave formed by the wire, tension is 70 over 0.03. Don't forget to square root. You will get 48.30 meter per second. So the unit should be an SI unit lah, because your mass in kg tadi, sorry, your tension is in Newton, your mu pun in SI unit, kg per meter. And then after that, after we calculate velocity, we want to calculate frequency. Of course, we need to know what is the lambda, because from this formula, if you want to calculate fundamental frequency, you can label as F1. So your lambda should be 1. Okay, so velocity kita dah ada. Now we want to calculate lambda 1. So what is lambda 1? So to calculate lambda 1, of course, you have to draw the standing wave formed by the wire for the fundamental frequency. So fundamental frequency is F1. Okay, so the shape of the standing wave should be something like this. Okay, so we have to draw one solid line, and the bottom one should be dotted line because it's reflected. Okay, so this is node and the next node. That is the fundamental ataupun the first harmonic of the standing wave formed by the wire. Okay, and we know that the length of the wire is 1.0 meter. Okay, Also, we also know that from node to the next node, it will be lambda over 2. Okay, so paling senang if we just assume one complete cycle like this, it will be 1 lambda. Okay, it will be 1 lambda. So if you want only half, that is lambda over 2. Okay, so from here we can calculate lambda. Okay, that will be the lambda 1 for fundamental. Okay, so lambda 1 ataupun lambda 1 over 2 is equals to 1.0 meter. So your lambda 1 should be 2.0 meter. And then after that, go back to your formula for velocity of the wave. V equals to F1 lambda 1 to calculate the F1. Okay, so V equals to F1 lambda 1. V is 48.30. F1 lambda 1 should be 2.0. And then rearrange the equation, you will get frequency for fundamental is 24.15 Hertz. Okay, that is the fundamental frequency for the wire. Okay, so how about the third overtone frequency? Third overtone frequency. So third overtone is actually berapa harmonik? So we have to know berapa harmonik for third overtone. Okay, so let's try. So we already know there will be 3 cases for standing wave. The first one is produced by the string. Okay, so kita buat conclusion sikit lah. So the first one is produced by string. And then we have standing wave formed by open end tube. Number 1, number 2, and number 3, one end closed, tube with one end closed. Okay, so the first two for string and open end tube, you will have all harmonics. Okay, apa yang dimaksudkan dengan all harmonics dekat sini? So if let's say your n equals to 1, meaning it's fundamental. So if n equals to 2, that is called fundamental. Fundamental or known as first harmonic lah. Okay, so n equals to 2 is known as first overtone or second harmonic. And then n equals to 3 is known as second overtone or third harmonic. So if it's very important to know what is the harmonic number of harmonic n. And then for one n closed, we only have odd harmonic. Okay, so if odd harmonic, so we only have n equals to 1, n equals to 3, n equals to 5, and so on. So odd number. So if we start with fundamental as well, first harmonic, and n equals to 3 is called third harmonic. But for overtone, it's still first overtone. Okay, so we want to focus on string here. We have all harmonics, so we want third overtone. So your third overtone, it should be n equals to 4. Okay, so third overtone is actually fourth harmonic. That is n equals to 4. Okay, because after 3 is 4 lah. We want third overtone kan. Second overtone is n equals to 3. Your third overtone is n equals to 4. So as simple as we already know the fundamental frequency is F1 equals to 24.15 Hertz. To calculate F4, you just times 4 with F1. Because we have one general formula to calculate any harmonic or any frequency for any harmonic, it's Fn equals to n times with fundamental. So that is the general formula. For all 3 cases, for string, open end tube, and one end closed. Okay? But bear in mind, for one end closed is only odd harmonic lah. Your n should only have n equals to 1, 3, 5, and so on. That is for odd harmonic. Tapi for this string case, we have n equals to 4. So to calculate the third overtone or fourth harmonic, the frequency of the fourth harmonic, so just times with 4. 24.15 and you will get the answer 96.6 Hertz. Okay, so that is for question B. Question 9B1. So we have another question is 2. If the tensional force of the wire is double, okay, tadi tension kita is 70 Newton, now we double the tension, determine the new fundamental frequency. So, if we use tension equals 70 Newton, we get frequency fundamental will be 24.15. What will happen to the fundamental frequency if the tension is double? So let's double check what is the relation between tension and frequency. So I just write it here. Okay, that is for question 2, part 2. Okay, for question part 2, what is the relation between tension and frequency? Relation between tension and frequency. So, we know tension, we have the formula of V equals to tension over mu. That is the relation between tension and V. And then we also have relation between V and F. So V equals to F lambda. So there is no direct relation between tension and F, but we can conclude that tension and F is actually related by these two formula. Okay, so if we substitute F lambda into here, it will be T over mu here. So you can see that your frequency and tension is actually directly proportional. Okay, so your frequency is directly proportional to the square root of tension. Okay, don't forget the square root lah. Square root of tension. So ini benda yang paling penting untuk kita tengok relation between frequency and tension. Okay, so given that in the question, the tension, the original tension is 70 Newton. So we can simply write as T1 maybe, or T original, T1. So the frequency, the fundamental frequency, it will be 24.15 kan tadi? What will happen if the tension, the new tension is double? So 2 times tension 1, or you can write the value 140 Newton, 2 times 70. What will be the F new? Okay, what will be the F new? So we have this relation here, frequency and tension. Okay, so you can just use the ratio F1 over F new equals to tension 1 over tension new. Okay, or maybe you can substitute new as 2, T2 at F2. It's up to you. Okay, so your frequency 1 is 24.15 Hertz. F new is the one that we want to calculate. T1 is 70 square root. The T new, you can just put the value. Okay, and then you can cross multiplication. 24.15 times with 140 cert equals to F new cert 70. Then you end up get the new frequency that is 96.6 Hertz. So easy relation between tension and frequency. So we can simply get the new frequency if the tension is double. Okay, so for the same question, for the same year, 2018 and 2019, we still have another question for question 9, which is question 9C. That is related to source of the sound and relate with power and intensity, or maybe apparent frequency heard by an observer. Okay, so let's read the question first. The question give you stationary loudspeaker, so that will be the source of the sound, radiate sound with frequency 1000 Hertz uniformly in all direction. So if we can label frequency of 1000 Hertz will be frequency of the source. Okay, and then the source is stationary, so that means the loudspeaker is not moving. The source is stationary, the velocity should be 0. We can also label as V source is 0. Okay, and then at the distance of 4 meter from the point source, from the loudspeaker, the intensity of sound is 0.95 watt per meter square. Okay, so R is the distance from the point source, so we can label as R equals to 4.0 meter. And at that point, the intensity of the sound is 0.95 watt meter negative 2. So, the first question, they ask you the power of the loudspeaker. So, for the first question, we have one formula that relates intensity and power, which is intensity equals to power over area. So, this area, it should be surface area of sphere. So, why is it sphere? Because we know that sound will produce in all direction. In all direction. So imagine this is loudspeaker, so it will produce in all directions. So we can imagine this as a sphere. Okay, so that is why we use the surface area of sphere. And what is the formula of surface area of sphere? Is 4 pi r square. So we can substitute the value of intensity here. We want to calculate the power. The area, the formula is 4 pi r is this one, the distance from the point source, so which is 4.0 square. Make sure you substitute first and then you can calculate the power. It will be 191.01 watt. Okay, the unit for power. That is for question 1. Simple. For question number 2, they ask for frequency of sound heard by a child. So the child as the observant. So we want to calculate the apparent frequency heard by the child if he approached the sound at the speed of 10 meter per second. So the observer or the child is now moving or approaching towards the loudspeaker at the speed of 10 meter per second. So to list out the information, we have velocity of the observer, which is 10 meter per second, and we want to calculate the apparent frequency or frequency of the observer or the child, and then we already have the velocity and frequency of the source or the loudspeaker. So velocity of the source, we denote as source as S, which is 0 because the loudspeaker is not moving, but the frequency of source is 1000 Hertz. And then, from Doppler effect, we know there is one formula to calculate the apparent frequency, which is F naught equals to V plus minus with V naught over V minus plus with Vs bracket times with frequency of the source. So first you need to know what is V, what is V naught, what is Vs, Fs, and also F naught. So of course the O here represent the observer. Okay, frequency of the observer, velocity of the observer or the child. But the S here represent the source or the loudspeaker. How about V here? V here is the velocity of sound. So in the question, they already give you velocity of the sound or speed of the sound is equal to 330. Okay, so to know the F naught, we need to substitute V naught, Vs, and also Fs. But don't forget, we have to choose the plus minus sign here. How to choose? Is it plus or minus? Okay, so we know that this is the loudspeaker. It will produce sound in all direction. Okay, that will be the child is moving towards the loudspeaker. Okay, with the velocity of 10. Okay, that is the direction of velocity of sound. This one, velocity of the sound. We need to choose the side near to the child. So velocity of the sound is moving to the right, focusing on the side near to the child, near to the observer. So if we see that the arrow here is opposite direction. So if V of the sound is opposite direction to the V of the observer, we have to choose plus if it's opposite. If it's opposite. So you have to memorize lah. If it's opposite, you have to choose plus. If V sound is in the same direction as V naught, so you have to choose minus. Okay? So the same thing as V source. Let's say the loudspeaker is moving. not the observer. If it's plus, it should be opposite direction. Okay, so we want to choose plus. Okay, we want to choose plus. This plus, because it's opposite to the velocity of the observer. So velocity of sound is opposite to velocity of the observer, so we should choose plus. So V is 330 plus with V0 is 10 over 330 again. So for the denominator, we have to choose minus lah, because plus will couple with minus. That's why yang bawah kita letak minus plus, not plus minus. Okay. Then VS is 0. So doesn't matter sebenarnya sebab VS kita memang kosong pun. Your FS is 1000. And then calculate. You can calculate the apparent frequency. It will be 1030.30 Hertz. So of course you can see that frequency heard by the observer is greater than frequency sound because it's moving towards the source. Okay. The next question is from PSPM 2019-2020, question 9, still in chapter 10, mechanical and sound wave. So let's read the question first. A 1.53 meter closed pipe makes a humming sound at frequency 282 Hz when the wind blows across the open end. So this is an example of stationary wave formed in a closed pipe. So bila dia cakap close, it doesn't mean that both ends close. So close means one end is closed, the other end is open. And then the speed of sound of air is 343. With the help of a diagram, determine the number of notes in the standing wave. So to determine the number of notes, of course, it's better for us to draw the stationary wave. But we have to know what number of harmonic represented by this frequency, because it's just stated frequency. So it doesn't give you the number of harmonic of that frequency. So we have to know what frequency is that, what end is that. So first, let's list out the information first. Okay, so given length of the pipe is 1.53 meter, and then we have frequency which is 282 Hertz. We also have V of the sound which is 343 meter per second. Okay, so we don't know the frequency here represent to which harmonic. Okay, which harmonic is either N1, N2 or N3 and so on. Tapi what we know that for closed pipe, they only produce odd harmonic. Okay, odd harmonics. So that means we only have N1, 3, 5 and so on. So it could be 1, it could be 3, it could be 5. So we never know. But we need to identify the harmonic. Okay, so can we calculate the fundamental frequency, the first harmonic? So usually we can compare any harmonic, any frequency with that fundamental frequency. Okay, so we have one general formula for closed pipe for first harmonic or fundamental, which is V over 4L. Okay, usually we tend to memorize this general formula. Okay, but if let's say you don't memorize it, you can simply derive the formula by drawing the first fundamental, the first harmonic. So this is an open end, closed end pipe. The other one is open. So you can simply draw the first harmonic of the stationary wave like this. So one line is solid, the other line should be dotted. Okay, so you know that this is the length of the pipe, which is 1.53, so that will be the length lah, the length of the pipe, and we have to relate the length and the lambda. That one should be lambda over 4, so your length is equals to lambda over 4. And then by referring to the formula of V equals to F lambda, if you want to calculate F1, you have to put the expression for lambda 1. So that will be the lambda 1 because this is the first harmonic. So rearrange the formula. V equals to lambda 1. Lambda 1 is actually 4L. So you can simply get the formula for fundamental frequency. Okay. So F equals to V over 4L. So we already have V of the sound, which is 343, and we also have the length of the pipe. Okay, we can calculate the fundamental frequency of the wave. Okay, so 343 over 4 times 1.53, so it will be 56.05 Hertz. Okay, so that is the fundamental frequency. Then we can compare this fundamental with the frequency given in the question. Okay, because we know there is a relation between fundamental and the number of harmonics for any frequency, for any harmonics. Okay, so Fn is equals to NF1. Okay, you have to just times with fundamental frequency to get any frequency for any harmonics. But bear in mind, we only have odd harmonic here. Okay, just simply substitute the value and then fundamental. You will get N is 5.03. So we can assume it's fifth harmonic. Okay, so fifth harmonic, so N equals to 5. Okay, then we can draw the stationary for fifth harmonic. So for fifth harmonic, that is the closed pipe, one end closed, the other end open. Okay, so first harmonic. Okay, first harmonic. Okay. And then first harmonic, then second harmonic, third harmonic, 1, 3, and then you have to open a bit, another one, that will be the fifth harmonic. Okay. That one is first, third, fifth. Okay lah. So that is N equals to 5. Alright. So fifth harmonic. Okay. Or we can also say it's second overtone for fifth harmonic. So we want to calculate. Question asks you, with the help of a diagram, determine the number of notes. So we can simply write how many notes for fifth harmonic. We have 3 notes. So the answer, number of notes should be equals to 3. That is the answer for 9B. Okay, so as simple as that. So we have another question for the same year. We have 9C. So let's proceed to 9C. So this is the questions that relate with Doppler effect between moving source and stationary observer. So given in the question is frequency of the whistle by a moving train and frequency heard by the stationary observer is 520 and 460 Hertz respectively. So we have 2 frequencies here. The first one is frequency by the source. Our source is the whistle in a moving train. So frequency of the source is 520 Hertz. And frequency heard by the stationary observer, that is the apparent frequency, FO, or observer frequency, which is 460 Hertz. Okay. If the speed of sound in air is 343 meter per second, calculate the speed of the train. So the question asks you to calculate velocity of the train. That means velocity of the source, because our source is whistle in a moving train. So if you compare these 2 values of frequency here, you can see that the apparent frequency is much lower compared to the source frequency. So the observer heard a lower frequency compared to the frequency of the source. Okay, so we can imagine that, of course, that the train is moving away from the observer. Okay, so we can conclude in that way. The train is moving away from the observer because the observer heard frequency less than the source frequency. Okay, so by using the Doppler effect equation, we have F naught is the F observer, V plus minus V naught over V minus plus V source times with F source. Okay, so we want to calculate Vs here. Okay, V of the moving train. Your V naught is stationary. Okay, because the observer is not moving, so your V naught is equals to 0. But we need to check whether the sign should be positive or negative for this one. Because V naught here is 0, so doesn't matter lah, plus or minus. The main thing that we have to decide is the plus minus sign here. Okay, so to check the direction, if it's negative, Vs should be same direction as V. If it's positive, Vs should be opposite direction to V. So V here is the V of sound, which is 3 for 3. So we have concluded that the train is moving away from the observer. So imagine this is the observer, O, stationary. So our V naught is 0. V of the observer is 0. And the train is maybe it passed through the observer and then it moved away from the observer. So we can conclude this is V source. This is the one that we want to calculate, moving away from the observer. But the whistle will produce a sound in all directions. Assume this is the direction of the sound wave. So we can conclude that V sound is in this direction because we are focusing on the side where the position of the observer. So if you can see here, V source, sorry, this is not V source, this is V sound, sorry. So I shouldn't label as Vs because it makes me confused between which one is Vs. So this is V sound, Vs is V source. Okay, so V sound is to the left because it's our observer is to the left, and then Vs or V source is to the right, so it's opposite. And then if it's opposite, then we should choose plus between V sound and Vs, V sound and V source. Okay, then we substitute the value 3 for 3. So if bottom is plus, above should be minus 0. 3 for 3 plus with Vs, because we want to calculate Vs. Fs is 520, and then F naught is 460, and then rearrange the formula, you will get your Vs is 44.74 meter per second. That's the answer. Okay, so this is one of the question in Physics X, last batch 2020-2021, question number 5. Okay, so this is related to learning outcome 10.3, which is sound intensity. So the first question, they ask us to sketch a graph to represent the variation of I with distance r from a source that emits sound uniformly in all directions. Okay, so we know that sound deliver or sound travel in all directions. So that's why we have to use the formula of surface area of sphere, that is A equals to 4 pi r square, to represent the to picture the how the sound travel in all direction. Okay, and then r here represent the distance of a point from a source. Okay, so to know the relation between intensity and r, we have one formula, that is intensity equals to power power over area. So this area is actually area of the sphere. So we can expand the formula to 4 pi r square. So from here we can see that I is actually inversely proportional to r. Okay, so I is inversely proportional to r. So we can sketch the graph of I versus r. So this is y-axis should be I, x-axis should be r, and the relation is inversely proportional. So as simple as that for question number 1. And then for question number 2, the intensity of sound at a distance of 150 cm to the left of the speaker is 180 watt per meter square. Determine the sound energy produced by the speaker for every 1 second. So they ask you to calculate sound energy E. So we still use the same formula, which is intensity equals to power over area, where the area is the area of the sphere. But now we have to relate this power with energy. So we have one formula that relate power with energy. So power is equals to energy over time. So we learned this in chapter 5. Okay, so power is equals to energy over time ataupun rate of work. Okay, rate of work is being done. Okay, so if we substitute the equation of power, energy over time, into the equation of intensity, so it will be energy over A times with time. So your area is the area of the surface area, surface area of a sphere. So energy equals to 4 pi r square. You have to times with time. So formula will become like this. Okay, so you want to calculate energy here. So r is the distance from the point source. So given in the question, 150 cm is the distance to the left from the speaker. So that will be the r. Okay, so our r is 150 centimeter. So we can convert to meter. So it will be 150 times 10 to the power negative 2 meter, or it's 1.5 meter. Okay, so now substitute intensity is equals to 180. Energy over 4 pi, 1.5 is the r, times with 1 second. Okay, because the question asks you to calculate the energy of the speaker for every 1 second. And then kira, and you can get your energy of sound produced is 5089.38, and the unit would be joule. Okay, so that's all. Thank you.